So in last class I have solved some 3 mark questions, and today also I am going to solve some more 3 mark questions again from the same topic, that is differentiation. Look at the fourth question. Differentiate sin square x with respect to e to the power of cos x. This is what somewhat different type question. Again the two functions are given. Sin square x is one function, trigonometric function, and another one is e to the power of cos x. E to the power of cos x is an exponential functions. Whenever the two functions are given, okay, sin square x and e to the power of cos x, and these two are not parametric equations, these are not equations, these are functions, sin square x and e to the power of cos x. And here it is asked to find the derivative of sin square x with respect to the second function, that is e to the power of cos x. Here we have to take these two functions as a u and v. Okay, let us take the first function. Let u is equal to sin square x, and take second function v is equal to e to the power of cos x, e to the power of cos x. Let us take the given functions as u and v. Not only u and v, you can take two different letters like m and n, like that also. You can take any other letters. Okay, let me take these two functions as u and v respectively. Let u is equal to sin square x and v is equal to e to the power of cos x. Now differentiate these two equations with respect to x only. Differentiating both the equations, differentiating with respect to x, So derivative of u, take first equation. Derivative of u with respect to x is what? du by dx. And derivative of sin square x. Sin square x is not a standard function. You know the derivative of sin x. Derivative of sin x is what? Cos x. Derivative of cos x is minus sin x. Okay, they are standard functions. You know the derivatives of all 6 trigonometric functions, inverse trigonometric functions. But look at the higher powers like sin square x, sin cube x, sin to the power of 4x. So we don't have standard formula. For that, we have to apply the chain rule. Sin square x. So let us treat this sin x as simply x, and you know the derivative of x square. So what is the derivative of x square? 2x. Similarly, sin square x. Derivative of sin square x is what? 2 into sin x. Like derivative of x square, it is 2x. Similarly, derivative of sin square x is 2 into sin x. Now take the derivative of base. So derivative of base is what? Cos x. Differentiation of sin x is cos x. That is equal to, now use trigonometric formula, 2 into sin theta cos theta, 2 sin x into cos x, that is nothing but what? Sin 2x. Right? Using sin 2 theta formula. Sin 2 theta is equal to 2 sin theta into cos theta. So this is equation number 1. So we calculated du by dx, derivative of the first function with respect to x. And similarly, calculate dv by dx from the second equation. Again, now consider second equation. V is equal to e to the power of cos x. V is equal to e to the power of cos x. Now again, differentiating both sides with respect to x only, So derivative of v with respect to x is what? dv by dx. That is equal to derivative of e to the power of x. You know, derivative of e raised to x is e raised to x, but derivative of e raised to x, here the power is what? Cos x. So apply chain rule. So derivative of e raised to cos x is e raised to cos x. Okay. And take the derivative of power. Derivative of cos x is what? Derivative of cos x is minus sin x. Derivative of cos x is minus sin x. That is equal to, multiply the sign, plus into minus, plus into minus sin x into e raised to cos x. This is equation number 2. This is what dv by dx value. dv by dx is equal to minus sin x into e to the power of cos x, and du by dx is equal to what? Sin 2x. Now by using these two equations, we can get dy by dx value. Du by dv. Now derivative of first function with respect to the second function, that is nothing but du by dx. Now du by dv. du by dv. This means derivative of sin square x with respect to the second function, that is e to the power of cos x. Take the ratio of du by dv. Du by dv can also be written as du by dx divided by dv by dx. dv by dx. Okay, again dx and dx get cancelled. It is saying du by dv only. So let us write du by dv as the ratio of du by dx divided by dv by dx. Now du by dx value, you know how much it is. Look at the equation number 1. Du by dx, that is something but derivative of the first function. It is sin 2x. Sin 2x divided by, take the derivative of second function. Derivative of second function. See the second equation. dv by dx value is minus sin x into e to the power of cos x. Minus sin x into e to the power of cos x. So which is the required answer. And even once again you can replace that sin 2x by 2 into sin x cos x, so that the sin x will be cancelled. Yes. That is du by dv is equal to sin 2x can also be written as 2 sin x into cos x using sin 2 theta formula divided by minus sin x into e to the power of cos x. Now sin x and sin x get cancelled. That is equal to 2 into cos x, 2 into cos x divided by minus e raised to cos x. Minus e raised to cos x, which is the required answer. du by dv is equal to 2 cos x by minus e to the power of cos x, which is the required derivative of the given function. See the next question, number 5. If x is equal to a cos cube theta and y is equal to a sin cube theta, then prove that dy by dx is equal to minus cube root of y by x. Okay, it is a 3-mark question. Okay. Here, these two are again parametric equations. Apart from x and y, there is one more variable which is common in both the equations. That is what? Theta. Okay, we have to differentiate these two equations with respect to theta. And we need to prove that dy by dx is equal to minus cube root of y by x. So take the first equation, first parametric equations. Let x is equal to a into cos cube theta. Now differentiating both sides with respect to theta. Okay. Theta is a parameter. Now derivative of x with respect to theta is what? dx by d theta. dx by d theta. And a is a constant, write this as this, and take the derivative of cos cube theta. Again, you have to apply the chain rule for differentiating the cos cube theta. So derivative of x cube, you know, derivative of x cube is what? 3 into x square. Same manner. Derivative of cos cube theta is nothing but 3 into cos square theta. 3 into cos square theta. And take the derivative of base. Derivative of cos theta is what? Minus sin theta. Minus sin theta. This is what? Dx by d theta. That is dx by d theta is equal to plus into minus a into 3. It is 3a into cos square theta into sin theta. Cos square theta into sin theta. Let us say this as equation number 1. Equation number 1. So now take the second parametric equation. That is y is equal to a into sin cube theta. So this is what the second parametric equation. Now find out dy by d theta value. Now differentiating, so theta is a parameter. So that's why differentiating both sides with respect to theta. Differentiating both sides with respect to theta. So derivative of y with respect to theta is dy by d theta. Derivative of y with respect to theta is dy by d theta. That is equal to a is a constant, write this as it is, and take the derivative of sin cube theta. Derivative of x cube, you know, again it is 3x square. And similarly, derivative of sin cube theta is nothing but 3 into sin square theta. 3 into sin square theta. Now take the derivative of base. So what is the base here? Sin theta. and derivative of sin theta will be what? Cos theta. Differentiation of sin theta is cos theta. So I apply the chain rule for differentiating the sin cube theta. Okay, derivative of. So for the timing, initially I have to treat this sin theta as a simply x. Derivative of x cube, it is 3x square. Therefore, derivative of sin cube theta will be what? 3 into sin square theta, and take the derivative of sin theta. Derivative of base. Derivative of sin theta will be what? Cos theta. That is dy by d theta is equal to a into 3, which is 3a. A into 3a. 3a into sin square theta into cos theta. So this is equation number 2. So from these two equations we can get dy by dx value. Therefore, dy by dx is equal to dy by dx can also be written as dy by d theta divided by dx by d theta. Now, using equation number 1 and 2, okay, dy by d theta will be what? 3a sin square theta into cos theta. Okay, replace this dy by d theta by 3a into sin square theta into cos theta. Sin square theta into cos theta. Divided by dx by d theta. This is minus 3a into cos square theta into sin theta. Because derivative of a cos cube theta is a cos square theta into minus 3a cos square theta into sin theta. Now here 3a get cancelled. Even you can cancel 1 sin theta and cos theta. So dy by dx is equal to what? dy by dx is equal to what I got? Minus tan theta. So this is equation number 3. Now consider the RHS part of the proof. We need to prove that dy by dx is equal to minus cube root of y by x. So RHS part is what? Minus cube root of y by x. Now minus and keep this as this cube root of, put y value, y is nothing but what? A sin cube theta. A sin cube theta. Okay. Second parametric equation. And x is nothing but what? What is x value? A into cos cube theta. Now a and e get cancelled. Is minus cube root of sin by cos tan. That is tan cube theta. Now cube root and cube will be cancelled. Simply it is minus tan theta. Minus tan theta. Okay, look at the equation number 3. So dy by dx is equal to what? Minus tan theta. In place of minus tan theta, we can write dy by dx. So now let us replace this minus tan theta by dy by dx. Dy by dx. This is nothing but what? LHS part of the proof. That is dy by dx is equal to minus cube root of y by x. Hence it is proved. So take next question, number 6. If x is equal to a into theta minus sin theta and y is equal to a into 1 plus cos theta, then prove that dy by dx is equal to minus cot of theta by 2. Again, these two are parametric equations. X is equal to a into bracket open theta minus sin theta, and y is equal to a into bracket open 1 plus cos theta. Okay, apart from x and y, there is one more variable, that is what? Theta. It is a parameter. So now differentiate these two equations with respect to theta. Then you will be having dx by d theta value from the first equation, and from the second parametric equation you will get dy by d theta. Now take the ratio of these two equations, ratio of those two values. Then you will be having the derivative, that is dy by dx. So now take the first equation, first parametric equation, that x is equal to a into theta minus sin theta. Theta minus sin theta. Now differentiating both sides with respect to theta. Differentiating both sides with respect to theta. So now derivative of x with respect to theta is what? Dx by d theta. Dx by d theta. And a is a constant, write this as this, and take the derivative of theta. Derivative of theta with respect to theta is what? 1. Minus derivative of sin theta is cos theta. This is equation number 1. And take second equation. Y is equal to, second parametric equation, y is equal to e into 1 plus cos theta. 1 plus cos theta. Now differentiating both sides with respect to theta. So derivative of y with respect to theta will be what? Dy by d theta. Dy by d theta. Again, a is a constant, write this as this and take the derivative of 1. Derivative of 1 with respect to any variable, it is 0. Derivative of a constant function is 0. And derivative of cos theta will be what? Minus sin theta. Minus sin theta. That is equal to 0 minus sin theta is minus sin theta only. A into minus sin theta. A into minus sin theta. That is dy by d theta is equal to plus into minus. It is minus a sin theta. So this is equation number 2. Okay. From these two equations we can get dy by dx value. Now dy by dx is equal to dy by dx is equal to dy by dx can also be taken as dy by d theta divided by dx by d theta. Dx by d theta. So by using equation number 2, dy by d theta value is what? Is nothing but derivative of the second parametric equation. It is minus a into sin theta. See the second equation. Dy by d theta value is minus a sin theta, because derivative of y with respect to theta is nothing but a into derivative of cos theta is minus sin theta. So it is minus a sin theta. And dx by d theta, that is nothing but equation number 1. See the equation number 1, dx by d theta value, which is a into derivative a into 1 minus cos theta. A into 1 minus cos theta. This is what dy by dx. Dy by dx is equal to, we got here, I can cancel this a, minus sin theta divided by 1 minus cos theta. 1 minus cos theta. Okay, this is what the derivative of the given parametric equations. But look at the proof here. Here it is asked to prove that dy by dx is equal to minus cot of theta by 2. For that, we have to simplify this expression. We have to simplify this minus sin theta by 1 minus cos theta by using trigonometric formula. Our answer should be minus cot of theta by 2. For that, let us use half angle formula. Okay, dy by dx is equal to minus cot of theta by 2 ಅಂತ ಪ್ರೂವ್ ಮಾಡೋದಿದೆ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಹಾಫ್ ಆಂಗಲ್ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು. ಲುಕ್ ಅಟ್ ದಿ ಪ್ರೂಫ್. theta by 2 ಅಂತ ನೋಡಿ. This is what the hint. Okay, use half angle formula. Sin 2 theta ಅಂತಂದ್ರೆ 2 sin theta into cos theta. So now here replace that numerator sin theta by 2 sin theta by 2 into cos of theta by 2 by using half angle formula. dy by dx is equal to minus sin, keep this sign as it is, sin theta is nothing but 2 into sin of theta by 2 into cos of theta by 2 divided by, same thing in denominator also, 1 minus cos theta. 1 minus cos theta is nothing but it is 2 into sin square theta by 2. Sin square theta by 2. 1 minus cos theta value is 2 into sin square theta by 2. So 2 and 2 get cancelled, and even one term will be cancelled. I left with only cos theta by 2 divided by, write down the negative sign also, minus cos theta by 2 divided by sin theta by 2. Sin theta by 2. That is dy by dx is equal to, write this negative sign first, minus sign as it is, cos by sin, that is nothing but cot of theta by 2, which is the required proof. So I have solved 3 mark questions. So totally I I have solved 6 questions in part C, and in next class I will take 5 more questions. Okay, thank you.